Awesome. Well, welcome back. Amazing to see all of you here. And it's also my pleasure to be back at Build Stuff. I was at Build Stuff in Vilnius as well. It was amazing. So I'm pleased to be once again here with you guys. And today we will be talking about blockchain. And we will be talking about how we can build our own cryptocurrencies. And my ambition is that you will have good knowledge about how cryptocurrencies work and be able to do one on your own. But so first of all, who of you own cryptocurrencies? Any Bitcoin owners? Any Ethereum owners? Awesome. EOS owners? Any Bitcoin Cash? Anyone? Bitcoin Cash? One Bitcoin Cash holder. So it's good for me to see kind of what kind of audience you are and what are cryptocurrencies really? I mean, many people know that cryptocurrencies are around, many people know that cryptocurrencies are a thing, but what are cryptocurrencies? How many of you have heard that cryptocurrencies are a scam? How many of you think that cryptocurrencies are a scam? Ponzi scheme. Used for terrorist financing. Money laundering. We can talk more about that at the end if you have questions. We can discuss all of these topics, and they are very interesting. But because this is a software developer conference, this talk will be more about how you actually code cryptocurrencies and how you develop on blockchain. And if you're interested, we can speak about other topics as well. And so, one reason why cryptocurrencies are so important is because we are entering a new paradigm on the internet. We are entering internet of money. Because internet is amazing at transferring information. That is what the internet was made for and is working very well. However, now for the first time ever, we can transfer value over the internet. So that is why we say internet of money. Without intermediaries, we're now able to transfer value just like we're able to transfer information over the internet. Some people describe cryptocurrencies as decentralized networks. So you have a bunch of computers, they're all part of this network that is the cryptocurrency they are part of. Some people describe cryptocurrencies as protocols, as languages between computers. Some people describe them as tokens, and there is really a distinction between a coin and a token, which we will explore as well. And so all of these descriptions are true. I mean, some cryptocurrencies are tokens, some cryptocurrencies are protocols, some cryptocurrencies are decentralized networks. And so this is important to realize that there is not only one thing that is cryptocurrencies. Cryptocurrencies among themselves are quite different. And how many of you know how many cryptocurrencies are there on the market currently, approximately? Just raise your hand if you have any idea. Is it over 100? How many people think it's over 100? Is it over 500? Is it over 1,000? Is it over 1,500? Yes, it's approximately 1,600 different cryptocurrencies on the market. And the good question is, why do we need so many? We can discuss that as well. And whenever I talk about cryptocurrencies, there are obviously many questions. And this is something I've already told you, that people ask many different aspects of blockchain. Why is it here? Why do we have so many cryptocurrencies? What is the difference between Bitcoin, Bitcoin Cash, Ethereum versus EOS? I'm happy to answer all of that at the end, if we have time. And so, my name is Ivan, and I've been in the blockchain space since 2013. Originally, I'm a software developer. I've been programming since I was 9 years old. I've worked at Ericsson. I'm from Sweden, as the flag indicates. I worked at Ericsson for several years, and you might remember we were huge in the mobile space until Steve Jobs wiped us out. But also recently, I am on YouTube, and I'm doing YouTube a lot. All about cryptocurrencies, how cryptocurrencies work, how you program on cryptocurrencies. And my niche is that I really bring the technical aspect of cryptocurrencies and blockchain. How do they actually work under the hood? And so my YouTube channel is Ivan on Tech, and if you're interested to learn more, definitely follow me there. But with the growth of the channel, of course, you get a lot of speaking engagements, people want to hear, companies want to hear, and this also brings a lot of business. So therefore, we've also started Stockholm Blockchain, which is our consultancy where we implement blockchain solutions. We actually deliver blockchain applications and blockchain solutions to customers in many different countries all over the world. So this is what I'm doing currently. But it all started in 2013 for me, when I discovered Bitcoin and wanted to learn more. And so can you really create a cryptocurrency in under 15 minutes, as the title of this talk indicates? Well, yes, you can definitely create your own cryptocurrency in under 15 minutes, and you can find it on YouTube, and all the knowledge in the video, I will give it to you today, but in a more entertainment and in a more, contextual format. I will give you more perspectives and more context, but after this talk, I'm sure that you yourself will be able to do it in 15 minutes. So why do we need our own cryptocurrency? Why is it important? It's important for different people for different reasons. So for example, you see companies creating their own cryptocurrencies currently. Why is it so? Well, because they're interested in creating some kind of incentive model around their existing business model. We see social networks, such as, for example, Steemit, having their own cryptocurrency, basically paying content creators for content. Imagine if you received some money for each like you received on Facebook. Well, this is now possible with cryptocurrencies, where you are building this incentive structure. And cryptocurrencies are changing economies. For example, currently we have 12, 13 years old already using Bitcoin to pay for services. You have kids in high school doing financial transactions digitally, which was impossible when I was in high school, and it was extremely frustrating that I couldn't, pay my friends. But now it's for the first time possible. And when these people grow up and they turn 18 and they get their first bank account, their first banking card, and they will hear that, it takes several days to transfer internationally. It takes several days to transfer to US or Africa. They will just tell, their banks, why are you not using Bitcoin? Why are you not using cryptocurrencies? So economy is a huge part of the world that is changing due to cryptocurrencies when you have this global, permissionless financial system. Society is changing in many ways because you bring power back to the people, we remove intermediaries, and technology, because for the first time ever you're actually able to transfer value over the internet, and that brings its own family of applications. And as we described, incentives is a huge part of it, that you as a business can now build an economic model around your business model, existing business model, thus incentivizing customers to come back. That is why you see, for example, huge corporations such as JP Morgan very interested in this space. And why, for example, your normal grocery store in a few years might very well have their own cryptocurrency, because they already kind of have a currency. It is the discount coupons, all the loyalty points. They will definitely be cryptocurrencies in the future. And the next question is, of course, how? Once you have figured out why it is different for different people, the next question is, how can you do that? And there are really two ways to create your own cryptocurrency. One way is to launch your own network. As you remember, we described cryptocurrencies as decentralized networks. That is one way you can describe cryptocurrencies as. And the one way you can create your own cryptocurrency is by launching your own network. Having a bunch of computers, installing the client on each of those computers, and thus creating your own cryptocurrency from scratch. And the second way is to launch a token. And to launch a token, you need to program an application, program a small piece of code on an existing blockchain platform, such as Ethereum. And we're going to talk more about what it really means. And so, who know this guy, Charlie? How many of you know Charlie? One person, two people. All right, so can you tell me who Charlie is? Yes. So Charlie is the creator of Litecoin, and Litecoin started as its own network. They took the code from Bitcoin, because Bitcoin is open source. This is just a general trend and culture you have in cryptocurrencies, that everything is open source, because when you're dealing with financial systems, when you're dealing with financial transactions, of course everyone needs to verify the code. Of course you cannot trust a closed source cryptocurrency when you have billions, hundreds of billions of dollars in it. And therefore Bitcoin is open source, all of the cryptocurrencies are open source, and Charlie basically took the code from Bitcoin, copied it, made some alterations, and created Litecoin. However, what Charlie had to do was that he had to bring this code to his own network. He had to find the miners for his cryptocurrency, and he had to bootstrap everything from scratch. This is very hard. To create your own network is relatively hard. So when we are talking about these 1,600 cryptocurrencies that are on the market currently, very few of them actually have their own network. Most of them are tokens. most of them are tokens. For example, you have Golem, you have Augur, you have Civic. All of these cryptocurrencies are not their own network. Instead, they are running on top of Ethereum. And so, how many of you know this guy? Okay, so can you tell me, someone here, can you tell me? Yes, so this is Vitalik, the creator of Ethereum. So while Bitcoin is a cryptocurrency for financial transactions, you can do simple transactions, I can send you money, it has some simple logic. So for example, you and I, we can add simple logic to Bitcoin transactions. One example is that we can have multi-sig accounts. So let's imagine that you and I will have a company together, and I do not want you to spend our money without me, and you don't want me to spend the money without you. So we can create a multi-sig wallet that requires us both signing a transaction before this money can be spent. So this is an example of a simple logic you can add to Bitcoin. However, Bitcoin has the scripting language, however, it is not Turing complete. You cannot build whatever. You cannot solve any mathematical problem, computational problem with Bitcoin's scripting language. And this is just a design decision that Bitcoin team made. Because you have a network, what if someone writes an infinite loop? What if someone just burdens the network a lot by writing crazy code? So Bitcoin said, we are not Turing complete, we do not support loops at all. But Vitalik, he had other thoughts. He wanted to actually give Bitcoin a Turing-complete language, so you can write whatever application you want. And he tried to pitch it to the Bitcoin team, guys, why don't we have a Turing-complete language? But this idea never took off in Bitcoin. So therefore, Vitalik started Ethereum, which is a blockchain platform, but the difference compared to Bitcoin is that you and I can write our own applications on Ethereum. And so, for example, we can have a social network that runs on Ethereum in the decentralized manner, just like Bitcoin is decentralized. There's no central bank, there's no central entity, no central server. You and I can now write applications on Ethereum without central servers, without central points of failure, and they will be running in this decentralized manner. So this is what Vitalik really brought to the world, that you can execute code on the blockchain. This is revolutionary. There's also many problems with that we can discover under the questions and answers afterwards. And so now that you know what Ethereum is, we have to understand what smart contracts are. So when we're talking about executing code on the blockchain, you often hear about smart contracts. And smart contracts are small pieces of code on the Ethereum blockchain, for example, or on other blockchains that can handle money independently. So once you have a smart contract, this program, and it has money, it can hold money, you cannot just come and change the program. This program is immutable. It is on the blockchain, I cannot change it, you cannot change it, and it will just follow the logic that we have specified in the code. And so this is what we mean when we talk about that now people can have trustless business relationships on the blockchain. If you and I construct a smart contract with certain logic and insert money into it, I know that you cannot change it, and you know that I cannot change it. So for example, a practical example is that, let's say that you are my kids, and I tell you that, you know what, if you receive all A's, you get $100. So one way I could do it is I can insert $100 into the smart contract, we together program it, and then once the smart contract is launched, it holds my $100, and it can, for example, check with the API of your school, what grade did you receive? And then either pay you or pay me back. But there's no actual way for me to alter this code once it is live. And so this is really the beauty of blockchain applications. They are immutable. And it is revolutionary, but also problematic in many ways, as we will discuss later. And so to program smart contracts, you use Solidity. To program smart contracts on Ethereum, you use Solidity. And it is a language that is quite like JavaScript. And there's an interesting quote that has been said about Solidity that, Solidity developers make a lot of money. And the reason is not because it's hard. It's not because it's hard to learn Solidity, because no one knows it. There's a lot of money being poured into cryptocurrencies and poured into cryptocurrency projects. In fact, this is how much money that blockchain projects has raised since 2017. This is the summer of 2017. This is not even 1 year ago. And you see this complete explosion in blockchain funding, in blockchain projects being funded. So the reason why Solidity developers make a lot of money is not because it's hard, but because there are very few of them. And people still haven't discovered this new space of software development that is cryptocurrencies and that is blockchain. And so now that we know what smart contracts are, now that we know what blockchain, executing code on the blockchain is, we can talk about how we can launch a token on Ethereum. And so to do that, we need to implement something called ERC20 protocol. You can think of ERC20 as an interface, as a Java interface or whatever interface else. It just indicates that you need to implement certain amount of functions. And so this protocol is extremely popular. And the vast majority of those cryptocurrencies we talked about before, those 1,600 cryptocurrencies, they are implementing ERC20 protocol. And so because all of them are implementing the same functions, the same standard functions, this means that different exchanges and different wallets can easily interact with each other. And you can easily add new cryptocurrencies to exchanges, you can easily add new cryptocurrencies to wallets, because they're all working in the same fashion. But because we say that, it doesn't mean that they're all the same. They just have their basic functionality that is the same, but then you can add other functionality on top of that. So this is why ERC20 is so important, because it brings unity to the space and it makes it easy to add cryptocurrencies to, for example, exchanges, wallets, and so other software can integrate with your cryptocurrency very easily. And so one example that is very significant are decentralized exchanges, because when you have ERC20, you can actually trade cryptocurrencies without intermediaries. So EtherDelta is actually a decentralized application. It is a set of smart contracts running on Ethereum. And because all of these tokens you see here, all of them are ERC20 tokens, EtherDelta knows exactly how to interact with them and which functions to call, meaning that you have an exchange that is running completely decentralized. There is no one controlling this exchange. There is no one that can shut down this exchange. So imagine if New York Stock Exchange worked in the same way. If you just implement your own token, you can add it yourself and other people can start trading. So this is an example of a truly revolutionary thing on the internet, that you have decentralized applications that no one owns, no one can shut down. And this is possible due to the fact that we have standards, such as ERC20. And so this is the ERC20 interface. You have some basic methods. For example, you have a function to get the total supply of a cryptocurrency. You have a function to get balance of a certain address. You have a function to, for example, I can allow you to spend my money, and we have functions for that. And we have functions to transfer. Also, we have events. So events are slightly different from functions, because events basically allow me to make you able to listen to what happens in my smart contract. So for example, whenever there is a transfer happening in my cryptocurrency, for example, different exchanges can listen to this event that will be called when I transfer. Or when I approve you to spend my money, different applications, different exchanges can listen to this event instead, approval, and thus know what is happening in my smart contract. So this is how it looks. And how do we implement it? Because obviously this is an interface, now it's up to us to actually implement all of these functions. And we will be implementing a few of them. So how do we store balance is the first question. How do you actually store everyone's balance in your currency? Well, it is surprisingly easy. You just have a map. You have a map from address to an integer, and that is it. So as you can see, creating your own cryptocurrency on, for example, Ethereum is surprisingly easy once you start looking, behind the scenes, behind the curtains. And whenever people say that I have just created my own cryptocurrency, it might sound as something revolutionary. It might sound that they're extremely smart, but I mean, in reality, as you will now see, it's quite easy. So to store everyone's balance, you have a map from address to integer. So for example, if my address is 1 and I own 100 coins, you insert 1 into the map, you get 100 back. So that is our first question. The second question, how do you store allowance? Well, you have another map, but now you map an address to another map. So this way I can insert 2 addresses. So for example, if you're allowed to spend 100 of my coins, we can basically insert your address, mine address, and get how many coins you are allowed to spend from my account. So you get a feeling of what kind of data structures and what kind of variable types you have in Solidity. So mapping is creating a map, address, holds an address of an account, and the integer is an integer. How to get balance? Very easy. You just return you query the map with the token owner, the address of the token owner, and you get the balance. So this is how we can implement very simply one of the basic functions of ERC20, namely balance of. How do you transfer? For example, if I want to transfer something from me to you, how do you actually implement the code? Well, you need to implement the transfer function. And it is also quite easy because you query the balance of the sender. Basically, the sender is who is calling the function, message.sender, and you subtract the number of tokens I'm sending to you. So very easy, subtract. And then you add number of tokens to the receiving account, and you fire the event. So this is important for exchanges and wallets and everyone to actually see what is happening in our smart contract, in our cryptocurrency. How can I allow you to spend some of my money? Well, we query our allowed map, which in turn maps to yet a new map, and specify how many tokens. So this would be my address, message.sender. Spender would be your address if you're allowed to spend my money. And we just set an integer there and fire the event so that everyone, all exchanges, wallets can listen to what is happening in our smart contract. However, something to keep in mind is that not all tokens are 100% compliant. I mean, in many cases, maybe I do not even want you to have this functionality for approval. It's not all cryptocurrencies that want to have this, the full set of functions that ERC20 specifies and has it in its specification. So for example, you have Golem. They do not even support approval. All functions that have to do anything with approval are simply not present there. So this gives us a bit of flexibility. You don't actually need to have everything, and your token will still work fine. Golem is quite significant player in the field still. So what we have just done by implementing a few methods, for example, transfer, for example, balance of, and allowance, we've created a programmable digital token. It does nothing. It is scarce. We can specify how many of these tokens there are in existence. So what we have created is basically a digital scarcity that we can transfer to each other. And that is the basic layer of your cryptocurrency that all cryptocurrencies need to have, because otherwise there is no value in them. So we have digital scarcity and we can transfer it by implementing a few maps and a few simple methods that everyone can implement if you just had a month of programming. So what now? Is it all? Can we do something else? Well, to realize is that ERC20 is just a part of your cryptocurrency. It is the basic layer we've talked about. On top of it, you can implement a smart contract and add more functionality. So, for example, as we will see later, you can create a game that has an in-game currency that is decentralized. It is a cryptocurrency that can be traded. We will talk about that. But then you also might have centralized logic. So let's take a look at an example. So for example, let's say that we are game developers, you and I, and we have game backend. It is completely centralized. This is running on our server. And so when we're talking about blockchain, you hear a lot this word decentralized. It is that everyone is kind of addicted to this word decentralized. And what it means is that decentralized code is running on the blockchain. No one can go in and alter it once it is deployed. Centralized code is just normal code running on a server. If I own the server, I can whenever change it, I can whenever shut it down, and therefore you have the distinction, centralized, decentralized. So our game backend is centralized because there's no way for Ethereum, for example, to handle game logic currently. It is just too slow. Ethereum is very slow. It's one of those problems we have in the blockchain space. It's not very scalable currently. So, but we still can, add small things to the blockchain. For example, our in-game currency can be an ERC20 token, and suddenly our in-game currency is tradable worldwide, 24/7, without borders. Anyone can start trading it. And, for example, buy other cryptocurrencies with it, switch it to Ethereum, then switch it to Bitcoin on some other exchange. So you really have this flexibility of truly creating digital scarcity and adding it to your existing logic, business logic. Or another example is that you have items. let's say that I have a game and people who work for items, whether it's armor or a sword or gun or whatever, they know that there's a fixed amount of these items. No one can create more. I, as a game developer, cannot just print 1,000 more guns or swords or armors, and this gives these items value. I mean, now they are globally tradable. Everyone knows that there is fixed amount, or because we are programming these digital assets, these programmable tokens, we can make so that each day there is one new sword in existence. We can add inflation if we want. And this is also your flexibility. You can have a fixed supply if you want, or you can add inflation, or you can make it so that you're able to create new items if there is some kind of special event. But the truly important thing is that everyone knows what the code is and everyone knows how the code is functioning, because you are doing everything open source when it comes to these decentralized aspects. And is this flawless? Well, some people might say that this is real world trading. Game developers in some cases do not want that, and that is totally fine. It is not for all games. Therefore, this doesn't fit everything, but it gives flexibility to game developers to now add this. So this is a small example of how you can take your existing logic, your existing business logic, and add parts of decentralization, add parts of cryptocurrency, add parts of blockchain to that, and what kind of effects this might have. And so if you want to learn more about smart contract programming, definitely go to coding.ivanontech.com. We will teach you programming on Ethereum, on EOS, which is a new platform, and on NEM. And I'm on all social media. Just Google Ivan on Tech or email me ivan@ivanontech.com. So guys, that was all for this session. If you have questions about programming on blockchain or just cryptocurrencies, or whether cryptocurrencies are a scam or not, or whatever you want to talk about, cryptocurrency related, blockchain related, I'm here. I think we have 20 minutes or so. So please, any questions about cryptocurrencies? Thank you very much. Thank you very much. Yes. How it was created? It was created by Ethereum Foundation, and also in this decentralized open source manner, that you have a bunch of developers working on Ethereum, and then you have one developer proposing something. So for example, you can go to GitHub and you can create a proposal for Ethereum, and you say, let's change this. Or you might say, let's add a new interface, let's add a new standard. So this is how things are implemented and integrated in Ethereum and also in Bitcoin. I mean, all of us can go to Bitcoin GitHub and do the same, create a proposal. Please. Yes, so as far as I'm aware, there is no clear standard on EOS. And so the question is whether EOS has similar thing to ERC20. And EOS is this new platform that is coming out in June, promises a lot of scalability, a lot faster than Ethereum and many other features. So the question is, do they have some kind of own standard for tokens? And as far as I'm aware, there is no such standard, but there is no reason to not create it. I mean, it's very simple. We can create it in a week if we have consensus in the community. But it is definitely needed. It's absolutely needed. And yeah. No, it doesn't. It doesn't. Those are two different blockchains and two different systems. We might make it more convenient for developers, because they know I call this method to interact with tokens on Ethereum, and they also know I call exactly the same methods to interact with tokens on EOS. But just because they implement the same public interface doesn't mean that they are on the same. They are actually on different platforms and separated. Yes? Okay, yes? Uh-huh. So for example, this is just a function inside of a smart contract. Now, if we look at the whole interface here, here you can add more functions. So this whole, you see there's contract at the top. And ERC20 requires your contract to implement those functions. But here you can add other functions if you want. So here we can add extra functionality. So for example, in our game kind of example, you can have a function to, I don't know, if you, let's say you have a game and you need to combine resources to create items. Here's a function that can combine two resources, create a new item, and then put it maybe in a map somewhere. So this is just the basic, and then you can add more functions. You can also create different files and interact with different contracts on the blockchain. You can reuse code from other contracts. So it is, in that sense, you're not limited to those functions. Yes. So I mean, the interface doesn't care at all. You can add balances doesn't need to be named balances. It's all about how you name this variable we had here, and it's just an interface. You can implement it however you want. Maybe you do not want to use maps for some reason. You want to use some other data structure, or maybe you want to add more logic to transfer. So in that sense, the interface doesn't care. This is just the simplest implementation, and it's up to you how you want to do it. Please. Yeah, I don't have the number in my head, but it is as large as you. I mean, there is really no limit, as far as I know, because you have tokens that have millions and millions of users. Each user is an entry in this map, and so in that sense, it's all about how. And whenever you have a new contract on Ethereum, it burdens the network currently, and it's all about how Ethereum can scale long term. And that is why we have projects such as EOS coming with new paradigms for scaling and really making it more usable in everyday business logic that companies have. The way this works really, whenever you have a smart contract, all the computers in the network have a copy of that. And when you have a function call, for example, to a smart contract, all of the computers in the network need to execute that function call. They all need to reach the same answer. That's how you have consensus. And this is, of course, not scalable, because the more people join, now the more people need to execute. So in that sense, you want more people to be using Ethereum, but if they run their own nodes, it kind of makes the scalability worse. So this is one of the biggest issues currently. Please. Yes, it's hard. It's like it's a whole new mindset. So creating smart contracts is like hardware. It's more like hardware. Once it is on the blockchain, it is hard to do. But there are ways to do it. For example, you can have a proxy contract and then have one contract reference another contract. So it is solvable, but it's not easy. And this is why when you have a vulnerability in a contract that holds millions and hundreds of millions of dollars, this is something I talked about at last build stuff, all the hacks that have happened. And in many cases, hacks happen because people come from web development, for example, and they think as web developers that any time you can just make a hotfix and it will work. But this is like building a house. You need to really think about how you're building it. It's like building hardware. If there is a mistake, you are in trouble. And in that sense, you have a clash of best practices. So in normal software development, you want things to be modular. You want things to be, you have one module here, you can replace it easy, and if something breaks, it only breaks in one part. But in blockchain, it might be bad, because now if there is a vulnerability in this module, all the contracts that use it are now vulnerable. This is what happened in Parity wallet hack that was a few months ago. Basically, there was a library that all the wallets used, and this library got destroyed, and now all the wallets don't work. And therefore, I think the best smart contracts are very small pieces of code on the blockchain. You really need to be thinking about what you want to put on the blockchain, and don't just put things there because it's new and because people are excited. Really think about what you want to put. Have small piece of code describing your logic. Have many people look at it, because this will be handling a lot of money, your program, and it's a whole new mindset. I mean, you have programs actually deciding what to do with money, and of course, if someone finds a way to call. So the reason why Parity failed is because there is always a constructor function in this contract. We didn't talk about it, but there is a construction function. constructor function, just like in normal classes. And so someone was able to access it after the fact that contract was deployed. So the idea is that this constructor function should only be called once. But because of a vulnerability, a person from the outside was able to call the constructor once again, thus resetting the whole contract, and everything just stopped working. So there are many things to think about. It is important to have everything in mind that you cannot easily change, and do not think that we're building something modular and easy to upgrade. It's not like that. More questions? Yes. Yes. So there are projects doing physical goods by having a token. For example, there is a project called Bitcar, I think. They basically buy very expensive cars that they think will go up in value, because normal cars, they go down in value. But if you buy a very expensive exclusive car, it actually goes up in value. And this is a company, and they say if you buy our ERC20 token, you own a small part of our cars. And so when you have this kind of setup, you are trusting the company. So there is, of course, trust involved. And much like, for example, your grocery store might have loyalty points on the blockchain, and now they are globally transferable, and I can, for example, trade my flight bonus with your grocery bonus, and we're really redefining what is money, because now you can trade anything. Anything can be easily liquidated, and anything can be traded globally. And in that sense, some people are backing physical goods, but keep in mind that you're still trusting the company. And trust is also a very sensitive topic in the blockchain community. I mean, ideally, you want to have zero trust. In Bitcoin, you have zero trust. I don't trust you, you don't trust me. Blockchain will handle everything for us. We don't need to trust each other, because we know that blockchain will make sure that no one spends more money than they have, for example. And when you have a company offering digital tokens for a physical good, you have trust there, but it is possible, and many companies will do that, and are now doing it. You have more questions? Yes. Exactly. So, yeah. Yes. It's good. Yeah. Yes, so whenever you have a cryptocurrency, you really have to think about what is the value coming from. And let's say a simple example, Bitcoin. The value in Bitcoin is because it is permissionless. Anyone in the world can use it. It is globally tradable. You can send it wherever you want. And it is censorship resistant. There's no government that can shut it down. No one can really take your Bitcoin from you. And you might think, but why do we need that? I have my bank account, it's working fine. But if you think about how it is in Venezuela, where you have a huge inflation, and if you think about how it is in many African countries where you just cannot receive money from the outside without spending, half of your monthly income on the transaction fees, you start to understand by, these basic properties of Bitcoin have a lot of value. This is why the price of one Bitcoin is a lot higher in, for example, Zimbabwe at their exchanges compared to the US. Because in Zimbabwe, you actually need Bitcoin to survive. You need to store value somewhere, because your currency are losing value, by the minute. And so this is how you have value in Bitcoin. Then you also have Ethereum. And Ethereum, you have, let's go back to Solidity, wherever we had it. Here. So you have Solidity, and Solidity is a Turing-complete language. And you remember, Bitcoin, they didn't want a Turing-complete language, because Turing-complete means that you can write loops, and if I write some crazy loop, it will just burden the whole network, because everyone needs to run it. And so in Solidity, what you have instead is that you have gas. So whenever I have a smart contract that I want to interact with, I'm paying for each instruction in the smart contract. I need to pay for each instruction. Therefore, if I have a huge loop that burdens the network a lot, I need to pay for each instruction that loop executes. And so this is where the value of Ethereum comes from. It comes from the fact that if you believe that smart contracts, decentralized applications will be used more and more for different business applications, that businesses now can do trade internationally in this blockchain way, that you can have software actually dictating how financial transactions are done, then you understand that there will be more demand on each Ether, because now you have more people wanting to use the platform. In EOS, you have another paradigm, because in EOS, you use your tokens to vote. So in EOS, the value of the token is that you can actually vote on block producers. And in that sense, you decide where the network is going. In Ethereum, you cannot really vote for miners. Anyone can be a miner. You can join and mine Ethereum. But on EOS, we all vote for whoever is the block producer. So in Bitcoin, miners produce blocks. In Ethereum, miners produce blocks. Anyone can join. On EOS, you need to be voted. You're elected. And therefore, the value of EOS is that you have power of whoever is the block producer. But that is a very important question. We all need to really think about what is this cryptocurrency, why is it valuable, why are people buying it, and this is also what I do on YouTube, explaining why there are so many cryptocurrencies, what is each cryptocurrency made for, and why is it significant. And many of the cryptocurrencies are not significant. We also see many scams in this space, so I mean, all these 1,600 cryptocurrencies do different things, and I think as an investor, if you're interested in that, you really need to examine what you're buying, for sure. Yes? Yeah. So Hashgraph is, we mentioned that blockchains, they have a weakness, that is scalability. So in Bitcoin, I think you have like 5-something transactions per second. In Ethereum, you have 15 transactions per second. Hashgraph is basically coming out and saying, you know, we can have more transactions per second. And the issue with Hashgraph until recently has been that they are closed source. So this is where we're coming back to this question, why aren't they open source? And in my view, it is because they are targeting private companies and just businesses, public and private companies. So they have their own niche. They want to bring decentralization to the industry, but not in the public way. However, now you have a Hashgraph Hedera coming out. And so that is definitely interesting, and that is something I'm looking at as well currently. But I mean, up until recently, it's all been very closed, and there's a lot of marketing. Many people are excited, and many people ask me, for example, Ivan, what do you think? But up until now, we haven't really seen any public testing. How can you have a huge public network where anyone can join and start using it? And this is something I think we will see in the coming months. But Hashgraph is definitely interesting because they are bringing a new paradigm of how you reach consensus on the network. More questions? No, it is different. So Hashgraph is more, it's called the gossip protocol. So in Bitcoin you have miners, they are spending electricity, and they spend money because they're spending electricity. And then you know that miners are incentivized to play by the rules and do their job correctly because they have spent electricity and now they want reward. They want to earn money. So therefore, they are incentivized to play by the rules. Because if they cheat, if they, for example, if they include a transaction that is invalid, their block will not be accepted and they will lose money on the electricity. So that is how in Bitcoin you have this consensus that is backed by, indirectly backed by electricity, because miners spend money. And in Hashgraph, you instead have gossip protocol. So it is a network where everyone is just telling everyone what they have seen, what happened, and in that way you can build this mathematical model that can see who cheats. This is the step forward they are bringing to the blockchain space, that you have gossip protocol and everyone is just telling each other everything they know. And thus you can kind of build, the network can reach consensus and know indirectly by listening to everyone else what is true, what is not true. With probabilities, of course, it's all about probabilities. You had a question? Yes. Exactly. So it's like when internet was new. When internet was new, it was slow. It was, there was a lot of scammers, criminals, a lot of pornography, and many companies said, we like the idea, we like the technology, but we do not like internet. We like the idea of having a network of computers, but we do not like the internet. It's too criminal, let's not touch it. Much like you see people now saying the same about Bitcoin. We like blockchain, but you know what, Bitcoin, it's used for terrorist financing, money laundering, and we do not want that, but we want blockchain. And you saw, for example, companies such as Microsoft spending large amounts of money trying to kind of create their own internet. And this is why you saw intranets coming out. And the intranets were faster than the internet in the beginning, and they worked better because it is smaller scale. And you see a clear parallel to the blockchain world currently. Blockchains are slow. If you have a private blockchain, it is faster. But at the end, you realize that public blockchains will be more interesting. That is my personal opinion. Just like the public internet became more interesting because more and more people are developing on it, more people can collaborate on it, there is more value created on the public internet, and all of the scalability solves with time. It's just a natural feature of technology to improve and be more scalable. And much like the email was extremely slow in the beginning. You had to use the terminal, was not user-friendly, but then it worked. And then people wanted to do images on the internet. It was very slow, people said this will never work, very un-user-friendly, and then it worked. And then video, and now live streams. And so the same, I think, will happen with the cryptocurrencies and blockchain. Yes, there are use cases still for intranets. Intranets are still around. But the most interesting things are happening on the internet. And private blockchains can be used in, for example, a supply chain where you have different companies that want to keep track of each other. So if, for example, if someone catches fish, that's a company, someone processes fish, that's another company, and then someone sells fish, that's a third company. And so these three players, they want to keep track of each other and know where the mistake happened. So if a customer comes to the store and says, this fish is bad, well, you can kind of look at the blockchain what happened at each step. And this way, you can have three companies that are not really trusting each other and want to keep an eye on each other. They can have this distributed, decentralized network, keeping this database of records that if I'm the company in the middle, I cannot just go and change it. There's no one single person or entity or company that can change it. You can only add things to the blockchain. So there are, of course, use cases for private blockchains currently. But all of that can be done in the public way as well. Not currently because it's too slow, but in the future for sure. And so whenever you hear that this company is creating their own cryptocurrency or blockchain or wherever, it's like hearing this own company is creating its own intranet, but 30 years ago. Still there is a use case. I think there will always be a use case, but the use case will be smaller and smaller, the more interesting the public blockchain space becomes. More questions? Right, guys, that's it. Thank you so much for listening. Thank you for all the questions. It was a pleasure.